Hello friends, now we will discuss divisibility chapter. In that, next we will see the some theorems. The first theorem, a divides b, then a divides bc for any integer c. Now discuss second and third. We will discuss first theorem. So first theorem, proof. Given that a divides b, म्हणजेच by the definition of divisibility b is equals to x, therefore x belongs to any integer z. Equation number 1. Now multiply equation 1 by c. Multiply equation 1 by c. Therefore bc is equals to ac into x. C belongs to any integer z. Now bc is equals to a into xc. X belongs to z, also c belongs to z. Therefore bc is equals to a into x1 is equals to xc, and x1 belongs to any integer z. Therefore by definition of divisibility we can write a divides bc. By the definition of divisibility we can write a divides bc. Therefore first theorem prove. What is the first theorem? A divides b, then a divides bc for any integer c. Therefore we can prove that. Now we will discuss second theorem. A divides b, comma b divides c, then a divides c. We discuss the second proof. Proof second. Given that, what is the given? A divides b, that means b is equals to a x1. X1 belongs to z. Equation number 1. Second, what is the given? Also b divides c. B divides c. By the definition of divisibility, c is equals to b x2. X2 belongs to z. Equation number 2. Put. Now substitute. B is equals to ax1. B is equals to ax1 in equation 2. Put b is equals to ax1 in equation 2. We get c is equals to bx2. Therefore b ची व्हॅल्यू काय आहे ax1 into x2. Therefore x2 belongs to काय आहे? x2 belongs to z, आणि x1 x2 also belongs to z. Therefore which is equals to a x1 into x2. Okay, therefore c is equals to a x3. Therefore x1 into x2 is equals to x3, and x3 belongs to z. By our definition of divisibility we can write as a divides c. Hence the proof. काय प्रूफ करायचं होतं आपल्याला? a divides b, b divides c, then a divides ac. Therefore c is equals to x3. By the definition of divisibility we can say that a divides c. A divides C. Now third theorem. What is the third theorem? Third theorem, A divides B, A divides C, therefore A divides Bx plus Cy, where x and y belongs to z, any integer. In that we have to given A divides B. Therefore, by definition of divisibility, B is equals to Ax1, x1 belongs to z, equation number 1. A divides C. By the definition of divisibility, we can write as C is equals to Bx2. Bx2. Therefore, x2 belongs to z, equation number 2. Now multiply equation 1 by x and equation 2 by y. Multiply equation 1 by x and equation 2 by y. Therefore, Bx is equals to A x1 x. Therefore, x1 x belongs to z. C y is equals to B x2 y. Therefore, x2 y belongs to z. Okay, this is equation number 3rd. This is equation number 4th. Now adding equation 3 and 4, we get Bx, Bx plus Cy, Bx plus Cy is equal to Ax x1 plus Ay x2, Ax1, Ay x2. We take common A. Therefore, A common, x1 plus Ay x2, and we know that x1 plus y x2 belongs to z. Yes, this is belongs to z. Therefore, Bx plus Cy is equals to A x3, x1 plus y x2 is equal to x3, and x3 belongs to z. Therefore, by the definition of divisibility, we can write A divides Bx plus Cy. Hence, the proof. We have to prove A divides B, A divides C, which implies that A divides Bx plus Cy. Hence, we can prove A divides Bx plus Cy. Thank you.